I have another example problem here. The power output of the sun is 3.85 times 10 to the 26th watts. The sun is a perfect emitter, so it has an emissivity of 1. What is the surface temperature of the sun? Now, the sun emits electromagnetic waves. This is an example of using the radiation equation. You don't even need to know that it's emitting electromagnetic waves. Just seeing the statement that the emissivity is 1, that means E is 1. The only equation we have that has E in it for heat transfer is the radiation equation. So we need the emissivity. Sigma is that constant. A is the surface area that is emitting this energy, and then T is the temperature. dQ/dt is measured in watts, so that is the 3.85 times 10 to the 26 watts. We have E. I've already written it on the left, but I'll repeat it here. Sigma is a constant, which I don't recall off the top of my head. So 5.67 times 10 to the negative 8. 5.67 times 10 to the negative 8. And it does have units. It was watts per meter squared, Kelvin to the 4th. A is the surface area of the sun. We can assume, just because we don't have any other information to assume otherwise, that the sun is a sphere. And so the surface area of a sphere is 4 pi r squared. We can find this equation on the last page of the test notes. So R we need as well. Well, astronomical data, if we go earlier in the chapter, I might have passed it. There we go. The sun, just using this average radius value that we have in the test notes, 6.96 times 10 to the 8. 6.96 times 10 to the 8th meters. We can find the area. So dQ/dt, we can divide by E sigma, let me write that better, sigma, area 4 pi r squared. That will leave us with T to the 4th, which we take the 4th root of both sides, we can find the temperature. So our temperature will be, so 10 to the 26 in the numerator. E is 1. Sigma is 5.67 times 10 to the negative 8. The watts in the sigma are going to cancel with the watts in the dQ/dt. 4 pi r squared, well, this radius is in meters, and we're squaring it. So meter squared here is going to cancel with the meter squared in sigma. And then we're going to be left with Kelvin to the 4th. Oops. So when we take this to the 1/4 power, we'll end up with our answer in Kelvin. So 3.85 exponent 26 divided by all that stuff on the bottom. 4 times pi. Now I need to take that to the 1/4 power. This is telling me 5779. So approximately 5780 Kelvin is the surface temperature of the sun.